information. Our presenter today is Tony Salas. Tony's a veteran technician and instructor on light-duty diesel systems. He owns his own professional shop in Las Vegas and training company based in Las Vegas. So the title to our presentation today is Scan Data PIDS Analysis. So without further ado, Tony, I'll hand it over to you.
Thank you, Mr. David, once again. Beautiful September, nice and toasty here in Las Vegas. Hope you guys are doing cooler than we are. But the good news is they're saying it's going to taper off after Friday. So that'll be kind of nice because the weather's been really, really interesting. In other words, hot. So thank you again, Mr. David. Again, thanks, Lucas, for sponsoring this webinar. Yes, the topic of today is scan data PID analysis. When I was working on this presentation a while back, and believe it or not, I was even touching on it even right before I start teaching here today, because I'm like, I want to teach this, I want to cover this, I want to cover this. Please note that most of you do have my cell phone number, and I'm one of the few instructors that actually gives my number out. And I get an occasional email, and I get lots of text and messages about diagnostics. So for those of you that have been through my webinars, please note, I understand that some of you guys are a little bit advanced, but I get some guys that are really way on the other side that they need help. So in this case, some shops are doing fine, while some shops are struggling. And some of the things that I come across when I go to shops, because as you know, I get contracted, like I have a shop call me, say, can you come spend 3, 4, 5 days, work with the guys? But I also don't just teach, I also work and diagnose with them. So in this case, I like to take pride in the fact that I try to fix most of the trucks at the shops, which I have. But it amazes me the level of competence that a lot of technicians have, and I'm glad they want training. That's good. Don't think I'm putting you down, those of you that you think you are. But in this case, looking at scan data and doing PID analysis, it actually leaves me in awe of what we're seeing, and in this case, understanding what's going on. But before I get started there, I'm going to switch my screen a little bit here, and I'm going to go over to my let's see, let me go over it. I'm going to change now. The reason why I'm posting this up here, I'm going to change here, is the fact that you do have as hopefully you can all see my snap-on the Zeus screen right there, is that we tend not to know what's going on. For example, this is a snap-on Zeus, and I'm not saying this is the scan tool to have, but this is the one I use. I do have a gel test too, which I use a lot with medium duty, but the scan tool, this one I like. Now, let me tell you why I like this one is because it does have scan tool abilities. It has a generic OBD2, but it also has a scope and a meter built in along with your component tests, guided component tests. So therefore, I can't tell you lately how many shops I've been to that do have, for example, this scan tool, and we're just using it as a scan tool. That's it. They were only using pretty much just 20% to 30% of the capability of the tool. The second thing I want to showcase here is the fact that you can call me, and if you do have a Windows-based type of scan tool, I can log into it using like Chrome Remote Desktop like I'm using right here. So yes, the scan tool is actually on the other room right now, but it could be on the vehicle too. I was going to set it up outside of the vehicle, but I got nobody else here, so I figured I don't want the vehicle to walk away with my scan tool in it. So in this case, what I wanted to show you here is, when you, and I'm literally controlling the scan tool remotely. I'm on my tool. For those of you who haven't seen this, some of you have. But in this case, I can select a vehicle and I can go ahead and scan. But what I'm going to show you is the guided component test, because the subject of this webinar is, looking at PIDS. And what is PIDS? A lot of the PIDS is sensor input. So many times, technicians are, kind of lost, because I got to tell you, these last few days, I went through my service information. I was looking, what are the manufacturers providing for that entry-level technician or the novice technician or maybe the veteran technician that never took the time to learn sensors and inputs, right? What are we giving out? But I got to tell you, I was kind of disappointed, because if I compare, for example, Duramax in the early years, let's say going back to 2007, 2008, and I compare it to the new L5Ps in 2019, the information is not as much as what it used to be when it comes to PIDs, when it comes to sensor specifications, is not as elaborate as it used to be. And they used to have some, like Ford, for example, would have some diagnostics that they actually would tell you to follow. So it's all out there, and it kind of frustrated me because we should have at least some kind of chart that tells you step by step. Now there are symptom charts, okay? Ford has symptom charts, so if you got a no crank, no start, what they want you to do, and various other things that you can look at. However, though, the point I'm trying to get to is, do you know a specific PID reading? What is a PID? Parameter identification. That's what it means. Parameter identification. These are the lines of data available to you. I'll show you more of what the service information has to offer. However, though, in tooling with the scan tool, for example, I'm going to pick a GMC, for example, and I'm going to pick a 2015. In this case, this will be a Sierra with a 6.6. Let's see, do I have a 6.6? Yes, I do. And in this case, I want to load the 6.6, which is the Duramax, as you all know. Now, when I click on engine here, you're going to see that the sensors that we do provide and the other information we do provide is all product specific. In other words, when you're looking here at the 6.6, this actually pertains to the 6.6 Duramax. So in this case, you know, how many times have we dealt with a CKP sensor, right? Well, what the scan tool provides is actually the connector in view, the description of how the sensor works, because sometimes we need more information to help us diagnose. Excuse me. So with that said, you do have that available here. Now, this is your sensor description. Now, if I go to key on engine cranking test, it's going to tell me what kind of sensor read I'm looking at. So this is where the scope would come in handy. Now, if you're not a scope savvy person, believe it or not, this is the way to throw yourself in it if you have this tool, for example. So what I'm trying to say is I can look at the data right here. Now, obviously, when we're looking at crank and cam on the scan tool PID data, what are we looking for in reality to see if you're getting anything? Well, you're looking for an RPM signal. Your RPM signal is based on crank and cam. But if you want to scrutinize it further, you do have this service information available. Now, let me pick, for example, a very popular sensor that a lot of guys struggle with, and that would be the mass airflow sensor. So if I scroll on the mass airflow sensor, again, there's the description operation, there's the connector in view. It tells me what each wire is. However, though, can I actually use the scan tool to evaluate the reading? Well, in this case, it'll tell you a frequency test, right? Tells you what to test. In other words, you're hooked up live on the scope with the meter to know what's going on here. So in this case, that's what I'm looking at here. So this is live readings again, because you have to understand that you're looking live at the signal to see if the signal is dropping out. So there's 2 points to be made here. Is one thing is to look at your scan tool readings of a specific sensor or PID. Another thing is to hook up a meter or a scope to see it live, what the wire is doing at the connector or at the ECM, PCM. Okay. So, you know, that's where we get, that's the difference between finding an intermittent problem, an influence signal, or even a default signal as well. So therefore, this is nice and dandy, but the problem is that what if I'm looking at my PIDS? So I actually got myself out of there. Now, let me go ahead and stop the share here. So with that said, you know, what am I going to do? Let me go back up here, hit the wrong button, sorry. So what I'm trying to show you here is, let me go over here. My mistake, I hit the wrong button, sorry. But here you can see that I'm logged into the service information, and I'm looking at that PO102 mass airflow here, okay? Now, what I like about RAM Cummins is that when you pull up a specific sensor, you're going to get a wiring diagram with it, which again is nice and dandy. But in this case, your homework that you have to do to become a better technician is to obviously read the theory operation, or like we just saw on the Zeus, we just saw the description operation. So there's always a good understanding, because again, guys, I know some of this might be basic for some of you, but in my travels and in my phone calls that I get, a lot of technicians are dead lost on PID information, such as a mass airflow. So in this case, you're going to notice here that again, you got a wiring diagram showing you the mass airflow sensor right there, okay, along with your EGR cooler bypass, but in this case, that's part of the mass airflow sensor. So there's your wiring diagram. However, though, as I follow the steps of diagnostics, you're looking for specific readings that, and I'm not going to go through it right now, but it's going to tell you what is your reading on your mass airflow, blah, 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 using the scan tool. So it might ask you to do that, but it takes step by step what you should verify. So there's something to learn here. On step 1, 2, 3, and 4, and then finally at 4, it's telling you to measure the voltage of the mass supply circuit, that mass airflow harness connector. In this case, they want, before you even analyze the sensor, are you sure that the mass airflow sensor is getting proper battery voltage? In other words, a voltage drop test to the mass airflow, because you want to verify that it is getting voltage. So then it's trying to check the circuits too as you go along, right there. So again, you're looking for the circuits. Now, so I guess what I'm trying to show here as we look at this is the fact that, do we see any mention of using the scan tool PID chart in it to actually, test the mass airflow reading? No, many codes didn't have that. And I actually decided to review a few of these codes these last few days, and it was amazing. I'm like, well, we don't have anything. So what do we have here? Well, first of all, you got to dig, okay? Here you can see that sometimes with PIDs, you have to have, let me scroll up here. Sorry if it's a little blurry. I'm going all the way up since I can't access that other pin over here. But in this case, here you can see an L5P Duramax, and this is the pretty much all the parameter IDs that you have available, obviously in engine drivability. So in this case, this is kind of nice because it helps you decipher what does everything mean. Obviously, they start off with the 5-volt reference 1 through 5 circuit status. This parameter will display OK if the circuit is good or malfunction or is short to ground. Now, when I first saw this, I'm like, this is gold in reality, because this will tell me the status of the 5-volt reference circuit. Now, let's step back for a second. If we go back quite a few months, or if not a year, in our Lucas training webinar series that we've been doing, we did talk about, looking at a diagnostic trouble code. I think we had actually a whole webinar on that. And in this case, when we talk about diagnostic trouble codes, I've always said that a diagnostic trouble code is a test. And when a test has failed, that's when the code sets. Well, now they kind of, stepped it up. General Motors has definitely stepped it up. And in this case, when you look at PID data now, you're going to see the OK, not OK signals now on the PID list. So when you look at the 5-volt reference 1 through 5 circuit status, obviously we're going to have to look at the wiring diagrams to know which are we referring to, but I'm betting it's mass airflow, MAP, ECTs, ambient air temps and so on. So in this case, that use 5-volt reference. And in this case, you got to really take advantage of what the PID data is giving you, because it's clearly stating here that it will display OK if the circuit is good or malfunction if there's a short to ground, a short to battery power, open circuit is present. Now, if there is a malfunction, there should be a code that sets because the test has failed, and it'll show you that. So in this case, you'll be able to see that. And I guess what I'm trying to get at is, nowadays, and I'll show you, by the way, an L5P, and I'll show you a Duramax 3-liter LM2, PID list 2 live that I recorded. And in this case, you'll be able to see, if you got OKs or no OKs. So this is something that you can quickly see what's going on. Now, I know what you're thinking. Well, Tony, if it did see something that's not okay, should have it set a code? The answer is yes, you should have a code. But if you're doing a PID analysis, because a lot of guys will skip the codes maybe, and they'll go straight into PID analysis. Yeah, that's where you're going to go ahead and see that maybe I do have an issue, but I can look at the PID list to get an idea what's going on there. So now, as I scroll down the list here, what's available, please note, there's your APP sensor, for example, right? Not only is it giving you a value of what the pedal reading should read on your PID list for pedal not actuated or pedal, fully actuated. In other words, you got it on the floor, you don't have your foot on it, period. But again, I can read that this parameter displays the voltage signal sent to the control module from the APP1 of the APP sensor assembly. APP sensor 1 is a range of values indicating a low voltage when the accelerator pedal is not depressed, to a high voltage when the accelerator pedal is fully depressed. In other words, 0.7 to 1.2, no foot on it. Foot on it, 4.2 to 4.5, which your PID should read. So this brings up another point that I'll show, and I'll repeat again in the slides, is when you are analyzing, and this is probably the most important point of this course whenever it comes to PIDs, is when you are looking at any kind of signal whether it be MAP, APP, mass airflow, and so on, you want to look at the signal voltage. So in this case, you definitely want to look at the signal voltage. So in this case, if I truly want to analyze an APP1, let's see what the voltage reading is on the APP sensor. So you ask yourself, well, I don't know what it's supposed to be. You can look it up in the diagnostic trouble code if available, or you can look up these PID lists that are available in your service information. So this is straight from GM that you can access. So, this is pretty much very important. But it helps me understand what's going on. So again, if I do have an issue where the truck goes to idle only, and this happens, by the way, on the L5P, LMLs, all the Duramaxes, customers driving down the road going about 65 on the highway, all of a sudden the truck goes to idle only, definitely APP most likely. And in this case, you pull over the side of the road, turn the key off, then you go to turn the key back on, everything's back to normal. So obviously something dropped out in the APP. That's a very common issue we see there. So again, how can I analyze that? Look at my PID list and let's see if my voltages are between 0.7 to 1.2. And then with my pedal fully, actuated wide open throttle type of thing, 4.2 to 4.5, right? But you'll notice, though, to take it a step further, how PIDs have excelled. Once again, we talked about, okay, it says APP sensor 1 circuit status. So in this case, it's telling you the APP sensor 1 out of range indicates that the sense accelerator pedal position sensor value is currently out of range, or that a malfunction has been detected based upon the sense accelerator pedal position 1 sensor value being out of range. So there you can take a quick look. So if you want to role play this, if I have an APP sensor code, I can look at my PID list. Let's see what the status is of APP angle for this Duramax L5P. Okay, so a lot of good information as I keep scrolling. I'm only in the A's, by the way. This is all in alphabetical order, but in this case, you can keep going down the list to actually keep looking at the rest as well. Those of you that are in California, you got monitors you guys got to watch, right? So therefore, you can also find the status of a component monitor too as well. So therefore, you can't pass emissions unless those monitors are run and passed, so therefore they got to be set to pass. But again, we scroll down, and I know sometimes we take for granted, what we know already. We all know about, the balancing rate, but take a look at the one that's also on your L5P. The second one down, it says cylinder 1 through 8, compression test time after top dead center. This parameter displays the captured time it takes for the crankshaft to travel from top dead center to a calculated distance in degrees. The ECM stores the value from the latest perform engine compression test. A longer travel time indicates a bad cylinder. I bet you guys didn't know that one. So in this case, that's also another PID that's going to vary, but we can take a known good truck, because if you really think about it, crank speed is going to be really critical. Just like we do the cranking or the relative compression test on a Ford, we have to have a good crank, we have to have a good charge of batteries to do this. And in this case, he's telling you what it takes to travel in degrees. So it's going to be a degree reading. So we can actually start analyzing that. Now, GM doesn't give us, I looked up, GM does not give us a spec for it, but at least I know what to look for. So now I thought about this. I go, well, now that next time I play with more L5Ps, what I'm going to do is keep an eye on those captured parameter displays and what that degree is. So next time I look at this PID, I'll be able to see what is actually available. So in this case, that's something you can actually keep in mind there. But in this case, this is 1 through 8. So again, we'll get it to an L5P and we'll be able to look at that as well. Now, you got your obvious ones, and the obvious ones are like desired EGR position. If you've dealt with a lot of Duramaxes through the years, we know that they get carbon intake fouled intake in the intakes. So in this case, we can get a sticky EGR. We can have a PO101 code set. So in this case, you definitely want to look at the desired EGR position and the actual EGR position. And those are, to me, those are the easy PIDs. Like, for example, when I work on a Ram Cummins 6.7, the way I found a sticky EGR on those 6.7s is, again, look at the desired, look at the actual EGR PIDs on the scan tool. And I could tell you as I, open and close, or, by accelerating, you see it open and close the EGR, you're going to see that it's actually sticking, because the commanded will go to 20, but it's still stuck at 0, or vice versa scenarios. Very easy to understand. So another a good thing about using PIDS is you can actually understand if a certain actuator like an EGR is actually open and closing correctly. And then comes one of my favorites, and that's the desired fuel reel pressure. Okay. Uh, can't tell you enough about that when it comes to fueling. We definitely have to keep an eye on desired fuel reel pressure versus actual reel pressure. But again, we got to look at desired. I still get these phone calls. I still get them where they're asking me, "Hey Tony, what's the minimum rail pressure to get this truck running?" You know, there is no minimum. It's whatever it desires. Okay. So if it's desiring 8,000, it better get 8,000, 6,000. You guys heard me say that story too as well. Even when it comes to the vane position of the turbo too as well. So in this case, it's telling you again what the position of the turbo is, so you can compare the actual desired turbo position. This is great to eat, and I'm sure a lot of guys have used it through the years to help you out. So good info there. Now, if we switch gears and switch over to Ford, let me zoom this up. Get this out of the way. Hello. There we go. Here we can see a 2013 6.7 parameter ID. And in this case, we don't get much descriptions here. However, though, what I do have is deciphering the acronyms. And Lord knows it's hard for me since I deal with different diesels here. It's hard for me to keep up with all the acronyms that are available. Luckily, if you do have IDS, it does actually break them up for you. But since I've been using that top gun scan tool and other scan tools, it doesn't tell me what they mean. So it's a good thing to have this list. And in this case, it deciphers what the PID is. ECT1, ECT1V, ECT2, we can see all that, EGRA command. You know, some of it is easy to understand, but some of it, those of you that are novice at this, you do have a list that gives you, again, what each of those PIDs means. So that's kind of nice that Ford does give us that list as well. So does GM as well. But I guess what I'm trying to get to is you do have the ability to view all these various PIDs. So what we're also trying to get across with this presentation when I developed this was, are you taking advantage of all the PIDs list? So it's a good idea to go through the list because many of us will use a scan tool, but only learn on the scan tool once you're doing a diagnostic, but sometimes it's a good idea to hook it up. Let me just give you a sidebar here. You know, I just got a contract teaching gasoline, and in this case, I'm teaching gasoline and I got to tell you, I'm a little rusty on gasoline. But when I was looking at the service information and the data and so on, I was easily picking up a lot of stuff. But in this case, I had to learn all the different pits as they're set forth. So a lot has changed. But in this case, what I'm trying to say is the service information is time. So I literally sat in my other truck that I got, my gasoline truck, and started looking at the data too to start to learning it. And my neighbors thought I must have been crazy because I was doing this at about 11 o'clock at night when I couldn't sleep. I'm like, I'm going to go hook up the truck and look at data. In other words, you take investment in your time to try to learn more by, seeing what's on the scan tool data. I do it too, guys. I'm telling you, I do it too. So there you go. All right. So let me go ahead and do a new share here. Go back to my original presentation. So again, if you got any questions or comments of what I've been covering here so far, please do ask. But I do have a brief message here. What I started to say earlier is that attitude, man, because I go to some shops and the technician is really good. The shop owner tells me he's a great tech, Tony, but he just gets angry a lot. And he's the type of technician that says, why now they built it this way and this and that. It's the Democrats, Republicans, blah, 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 EPA and all this and stuff. The fact of the matter is that attitude sucks. I'm sorry to say that, but it sucks. And he gets frustrated because he hasn't fixed the truck. So I try to intervene, but I'm not, when I'm at the shop and, almost every shop I've been to has one guy that's the angry guy. And he's a good tech. But the problem is that he's got a bad attitude. And in this case, it's not knowing is not taking it up because you're saying no, it's not this, it's not that. And I've been seeing this quite a lot, you know, and I get emails and I respond to the emails and I tell them you must do this first. And all of a sudden I get a nasty email back and they're like, that's not pertinent to my problem right now. Yeah, it is, you know, but it's you're just closed up in a certain shell and you don't want to open away from it. And in the meantime, you're struggling, or maybe you're just replacing parts, right? So therefore, that's not a good thing. But then the experiences I have And that's why I say experiences is because I'm telling you this, because I see this a lot in the shop. And that means that, those phone calls that I get are really frustrating. For example, this morning, okay, this morning. How many times have we been teaching about Duramax and looking at the suction side? I would say that 60% of the technicians I've talked to out there still don't know what the suction vacuum is at idle, how to do a total suction test, what is a total suction, on under load when you're using the gauge on the Duramax. And in this case, that to me, that's one-on-one basics. So therefore, that frustrates me because of the fact that that attitude just, well, I just need to do it once, and I probably won't see another Duramax for a few weeks, and then I'll go back to that. Guys, I know these by heart because I've rehearsed them, I've taught them, I've used them all the time. And in this case, that's what you got to do too as well. So the same thing applies with PIDs. That PID list is pretty important. So, before I even get more into the PIDs, I already started looking at some, but what is a PID? Parameter ID, like I told you already, but you can look at it as you are looking, in other words, you're role playing the ECM PCM. So if I see a problem, like last month I talked about what was a P2707 code on a Duramax, and we found out the engine was running too cold. But the technicians saw no codes, had a threat going for the SER. In other words, it's going to derate, or it was derated. Excuse me, it was derated. And the problem is I went down the data because I'm like, okay, what is the computer seeing that he says that there's nothing wrong, but there is something wrong? And you're like, huh? Yeah, because the computer's not perfect. That's where I come in as a technician. You come in as a technician. So as I was scrolling down the PID list, there's ECT, engine coolant temperature, and it's staring at me at 157 degrees. And I've had the truck running now for over 30 minutes while I've been doing other stuff and checking every other stuff on the truck. I mean, so yeah, if you're familiar with Duramax, you'll know about the thermostat sticking open. But then once we get the truck running hot, then we had the reductant fluid quality test fail even though it passed earlier. Now, I know what you're going to come back and tell me. Well, Tony, it ran the reductant fluid quality test. Why did it allow it to run with the engine so cold? Well, there's a flaw in the program. Ta-da! But that's where you come in as a tech. So again, I saw the temperature was too cold. So some of the basic information is what we have to verify. Ambient air temperature. I mean, in my classes lately, when I do, instructor-led classes, I get my scan tool and I'll ask, "Hey Siri, what is the barometric pressure here in Las Vegas?" Right? And in this case, Siri will just respond. And kind of right now, by the way, it's trying to tell me the answer. So in this case, we find out that the barometric pressure is, 15 psi, and you're like, well, how is it 15 psi where you're at, Tony? Because Las Vegas sits at 2,200 feet of elevation. It should be lower than 14.7. Yeah, but we got a high pressure system moving through in weather. So can't tell you how many barrel sensors through the years I have found bad. So again, you're going to role play yourself as if you were the ECM PCM. And what I mean by that is, he can't physically measure, oh yeah, it's cold, it's moist air. No, it's in dry air, whatever it is. It actually heavily needs that information from those sensors. So if I have issues and really crazy issues, you're really going to have to determine what is the issue. And you're like, huh? In other words, if there's an issue with a sensor and something's influenced the surrounding of that sensor, let me give you a real far-fetched one. Years ago, I diagnosed a misfire. And turns out that misfire, they had done everything, from injector. What did they not do? Even they were just about ready to replace the computer because they couldn't figure out why it was misfire. Well, turns out that the coolant had heavy, electrolysis. So upon putting a meter in the coolant, found out that I had way over 8 volts. In other words, there was so much of an electromagnetic field around the coolant as it was circulating that the electromagnetic field was influenced the crank or cam sensor, which in turn caused a misfire. So yeah, those are things and it's not very common, this failure, but it has been known to happen. So one of the tests we do on trucks is we'll go ahead and test the coolant to make sure it doesn't have heavy electrolysis. But that addresses another issue. However, though, that's how far-fetched it can be sometimes. So an issue, what I'm trying to get at is when you're looking at PIDs repeating, is that you want to make sure you see what the computer sees. And we'll get into that more of value, but we got to be careful though. Note that input data can be either live or it could be a default value. Now, when we talk about default values, we talk about things that relate to, like limp mode or limp mode home, but we'll get to that in a second. But let's first look at this overall picture. Here's an early picture of all those inputs, and it's something that you got to pay attention to because when you're dealing with a code that cannot clear, you got an issue with a input or a drivability that's so erratic, you got to start off reading your PIDs. So I would suggest that you start using the record feature because I got to tell you, on that Zeus scan tool that I got, it does have record features. And if not, I could do a WinC, where I can actually start recording screenshots or do a print screen and start recording print shots off of your laptop or your scan tool, whatever, or something as frivolous as using your phone and taking a picture of the screen so you can start knowing what those values are. Yes, I do have a few albums in my iPhone that actually has a series of different screenshots that I've done of different trucks from 6.0 to 6.4 to Duramax to even some Isuzus that I've worked on too as well, those NPRs. So in this case, I definitely have done those. But in this case, please note, even something as frivolous as fuel level, right? Fuel level input is important because if you're familiar with regeneration, regenerations will not run if you actually have fuel too high, too full, or too empty. What about the brake switch input, the boost switch as we call it, brake on off input, right? So in this case, brake switch can also cause no regenerations to run. So therefore, that's another very critical one. It's not even listed here, by the way, but yeah, it is important to actually have brake pedal input. If you've been working enough with Duramaxes, you've probably done your fair share of replacing them, even on Power Stroke 6.4s as well that we have seen. So again, don't underestimate those PIDs. So I guess what I'm trying to say is definitely take a look at your PID list. As a matter of fact, let me go back here to where I was, and I'm going to go here. Hopefully I hope I didn't mess it up. Hopefully I can log back into it. All right, I'm back in it. So I think I remember the code. If not, I'll be out of luck. But let's see. There I'm connected. Okay, I'm back on the scan tool again. I just logged back into it. Yes, it's remote again. Pretty cool, huh? I think technology is a great thing, but we've had this for quite a while. Anyways, I'm going to get out of here. And what I'm going to do is I'm going to go home and I'm going to show you here some of on the scan tool here. It does have your let's see, I want to go live. Actually, I should have exited the whole vehicle, but let's see. No, let's go ahead and exit completely out of the vehicle because I'm still in a GMC. And here, let's try this again. Go back to vehicle. I'm gonna actually I'm trying to get into demo mode. So let's go down to demo mode. Really? And the reason why I was trying to get to demo mode and it won't let me get into demo mode, I would have to walk over to it to move it. Because this actually has. Okay, nope, not there. Oops. But what I was trying to teach, if not, I'll try again here in a bit, but not to waste time. But let's see if it'll do it this way. Nope, it didn't do it that way either. Okay, so there's some flaws in remote desktop there. Oh, there we go. It did scroll down a little bit. Oh, I gotta go one more bar down. One more down. It's on the next one down. But anyways, what we're trying to show here is, and by the way, now that I see it, the Mercedes-Benz for sprinters works very well on this tool too. I never used it much. I used my other scan tool for that, and I'm like, whoa, it's pretty good. So, damn it, I can't get into demo mode. Okay, well, let me skip back to the presentation. I'm sorry, but we'll go back. But what I wanted to show was I do have some other recorded PID list here, but I'll use that. So anyways, sorry it didn't work there, but what I'm trying to get at is you're going to have to look at all that information there coming in. So before we start analyzing even PIDs, please note that a PID is only as good as what it's reporting to. In other words, mass airflow sensor. Can a mass airflow sensor be incorrect? DPF loaded, can that be incorrect mass airflow reading due to the fact that it's backlogging, it's restricting the flow, and that could cause a mass airflow reading to read incorrect. So how many times have I taken, for example, I just did a 6.4, I took the map sensor out, and that map sensor was heavily coated with carbon. Same thing on a Duramax L5P. That can cause incorrect readings as well. So even though you look at a PID, and if PID's incorrect, it could be electrical, or it could be engine related, or it could be just something around the surrounding area of that input, such as that sensor, that can be the cause. So always keep that in mind. So this is where your diagnostic approach is, of making sure that you did all the basic checks when you first started your diagnostics. But then again, it also means you got to know your sensors, right? I mean, what is those sensor types? Are they potentiometers? Are they two-wire thermistors? Are they signal generators? What are they? AC, DC signals, So in this case, you got to know the sensors, how they work. Now, for the longest time, I've been offering people, just send me your email and I will send you, the Duramax. I've always loved it. I've actually had a guy that just took it and he says, Tony, I took time to read this book. I printed it up and I actually took time to read it. And I go, you did? He goes, yeah, because I learned a whole heck of a lot. It's an old book and it's the Duramax book you could see here. And in this case, you're welcome to have it for free. I'll email it to you. So my email is tsalas@dieseltg.com. I'll try to post it later. Just send me an email. And this thing covers a whole heck of a lot. For example, here's a good example of what knowledge you can get. The early type of LB7s, LMMs, LLYs, and there's a whole crap load of LBZs, they used what I like to call a two-tier engine coolant temperature sensor. And what you're going to look at there on the upper right of the sensor, you notice that that sensor is going to change reference voltage to bypass or add a resistor right here, which is a 3.65 kilo ohm resistor. And what they were trying to do with technology back in the day, as we follow, I don't know if you can see my cursor, but as the temperature was rising from minus 40 degrees Celsius all the way to 151 degrees Celsius, we saw a jump roughly at 1 volt. So in this case, at 1 volt, you would see the reference voltage, excuse me, not the reference voltage, but the actual signal voltage jump because the reference voltage was now going with or without a 3.65 kilo ohm resistor. So that would mean that if you were following and you're looking at the signal voltage, you would see a jump somewhere around 43 degrees C, which is pretty hot, by the way, 43 degrees C. So in this case, you would have seen that. Now, that probably is not something we use every day. However, though, it does give you an understanding of how internally the ECM would accommodate such a huge rise, a range in temperature. So therefore, that's a good example of the PID list there too. So, like I said, I've been talking about mass airflow sensors. Again, this book does go into the intake air temperature, the wiring, how it was set up. And I got to tell you, through the years, as I've understood sensors, because sensors do have a common thing. For example, most barosensors are three-wire sensors. Most mass airflow sensors have the intake air temperature sensor internally with it. So here you can see right here with the mass airflow sensor that the intake air temperature sensor readings are also shown along with their wiring. So again, other inputs that work together. Now, I know what you're saying, Tony, that's basic. I know that. Let me tell you, again, goes back to what I said earlier. How many shops did I go to where we're trying to look at a mass airflow signal reading and they they didn't know that there was a intake air temperature sensor inside of that. I'm like, wow, okay, well, to me that was a 1, 2, 3 basic, but a lot of guys didn't know. So again, we got to get up to speed with that. So that goes back to what we said earlier about knowing your sensors and what you're looking at. So very important. What's another popular one? Now I touched on it, but now I'm going to get into it is, and guys, I'm at the point where I'm telling technicians that have been working in the trade for a while, if you don't know common rail, you should know it by now. It's been around for a long time now. We're in 2024. It came out in 2001 for the light duty trucks. And in this case, you should know it, right? So popular PID that we like to look at is definitely, we like to look at the PID list for desired and actual rail pressure. Now, here on my old IDS reading on, I believe I was working on a 6.4 here. And in this case, what I'm doing is I'm setting up the bar chart. So therefore, depending what your scan tool you have, you can actually set up bar charts right there. You see the blue bars right there. Now, even the top done scan tool that I got in other scan tools, like even the gel test that I was also using, that actually has the ability to give up graphs. You can put up graphs to analyze it. Now, Presentation of how you're looking at helps you in your diagnostics, because if I'm working by myself, I don't have somebody to look at rail pressure when I'm doing a test drive in case I'm losing rail pressure under load. So therefore I use the bar chart. So as I continue to play this, this reading of these PIDs of the, as you can see, of the fuel rail pressures, we can see again, and I'm going to give an acceleration here. You can see the desired follow being followed by the actual. So as I test drive, this helps me say, yeah, I'm not losing rail pressure. The actual is meeting the desire. However, though, let me pause here. However, the thing you got to remember is, like I said already, and I even got a YouTube video on my YouTube channel about this, is when you are analyzing any kind of PID, and we mentioned this earlier, is you got to look at the signal voltage, right? Right off the bat, this is where default values come in. This truck I know will substitute a default value. And the way I know I'm in default is one of two ways. First of all, I will see that the fuel rail pressure signal reading, instead of reading 1.6, is going to be reading 0 or 5 volts all the time. If it reads 0 or 5 volts and never changes, you definitely got an open or a short to ground in that circuit going to the signal from the fuel rail pressure sensor. Okay. However, though, the other telltale is that the actual and desired are exactly the same. If they're exactly the same, that's definitely telling me I'm in a default value. So Power Stroke 6.7 does that, Power Stroke 6.4 does that, and even the Ram 6.7s do that. Okay, so in this case, this definitely tells you again that you definitely are in a default value. So we'll get more into default, but for now, what I'm just trying to show here is, again, you can look at signals right there. So definitely we can see how that rail pressure went up and went down as I'm testing this truck. Now, remember though, please keep in mind that when you're looking at this, one thing is to do it in the shop bay. Another thing is to go test drive to see where it's at, that fuel rail pressure pit. Very important to understand that. Now, a lot of guys like to look at the pressure control valve and the volume control valve. All I'm looking for is that the duty cycles are changing due to the fact that fuel temperature, engine speed, uh, engine temperature, there's too many factors. There's not a solid number that I can work. I could give you a range, but not really. You'll notice here, as I go back to idle speeds here, let me move this back a little bit. When I go back to idle speeds, as I play this, you're going to see that the numbers hover around 14 to 20. Then under acceleration, you're going to see it jump to the 20 percentile. But I haven't been able to actually come up with solid numbers that would help you. So I just keep my eye on desired and actual rail pressure, and that definitely does help. So let's hit hard and heavy on a default value when you look at a PID. We all address this as, you know, in other words, you lost a signal. So is it a function where a signal is lost? Will the engine still run? Because let me tell you, there can be default values that keep the engine from starting. What's the classic one on a 6.4? If you disconnect one of the, what is it, EGT2? If you disconnect it's EGT1, excuse me, exhaust gas temperature 1, and you leave it disconnected, you're going to see it that open circuit's going to show a default value of over 1200 degrees on the scan tool. At that point, you're going to reconnect it. It's going to actually read correctly, but the computer still thinks it's hot, so you will get a no crank, no start condition, right? The book says you got to wait, 30 minutes with the key on with that set. But what we like to do is we'll go up to the battery, we'll get the starter cable, we'll hit it the positive post, crank it with the key on, the engine will start, then it kicks it out of that lock condition. That's a classic example of a limp mode, right? So what happens when you disconnect the fuel rail pressure regulator when you actually are running a Duramax, right? You'll get no acceleration. So the default action is when it sees it can't control the rail pressure, it won't give you any acceleration, right? So therefore they can vary. So your job is to verify that you are in the default value. How do I know? Once again, look at the signal voltages. That's what you want to look at. So ECT, AAT, barrel, and so on, they do have a signal voltage you can observe on your PID list to make sure that you don't have a problem. So if it reads 0, or if it reads 5 volts, that's a telltale right off the bat for a signal voltage. You are definitely in a default value. You're like, well, why is the engine reading 180 degrees when I can see 0, volt 0 volts, on the signal reading for the ECT? Well, it's because it's popping up a default value. So we often refer to as default values to work with limp mode. But one thing that's big difference that you may not know is when the vehicle's in limp mode, it could be in limp mode where it keeps the engine running, but it could also be causing the vehicle not to start. So again, like it says on the last line, the secret to know how is look at the signal voltage. So here's an example. Working on a 2005 Power Stroke 6-liter, came in with a crank no start. You look at the ICP and the ICP Desire. Desire was 800, but actual was 345, and that's the maximum it would go. They pressure tested, they did all their diagnosis of a high pressure system, make sure you didn't have any leaks. Everything led to the high pressure oil pump. It had oil pressure, but it didn't have not enough high pressure. So everything led to H-pump, right? Installed, guess what? Same issue. So when I got called into it, I looked at the truck, and my habit is to look at ICP actual, ICP desired, and the signal ICP. And sure enough, I'm cranking on it, and I could see it desiring 800 or so, and I could see the actual going up to 345, and that's it, right? But when I was looking at the ICP sensor signal, it kept reading 0 volts and never changed. So that 345 was a default value. So since the computer could not control the ICP, it was keeping the engine from starting. Okay, so that's a good example of that. So in this case, how could the technician saved itself the replacement of that high pressure oil pump is to have looked at the ICP signal voltage. So once again, I can't say enough about that. You have to take a minute to look at what that ICP signal voltage is, or else you're going to get yourself in trouble. Have I stressed that enough? Look at those little signal voltages for those sensors. Now, I know that you're probably struggling with some reading. So here's another Ford chart here where you can see there's the sensor inputs. Now we saw a previous chart that shows you the breakdown of what each acronym means. But you'll notice for the Power Stroke 6.7, there's a reading for key on engine off, hot idle at 30 miles per hour and 55. So this is typical values. You're not going to be entirely accurate there, but at least you'll be able to get an idea what should read. For example, there's APP1 on this Ford product. The reading should be what? 0.80 with key on engine off, obviously with your foot off the pedal. But as you're cruising the speeds, you're going to hit the pedal. You're going to be around 1.29. So now they're giving you, certain values here. For example, mass airflow. With key on engine off, the frequency should be 700 hertz, right? So that's what they're looking at, right? Actually, that's an error. No, that's wrong. I just got a problem. No, unless it's a default, but I don't think it's a default value. Ooh. Now I got to get on the Ford to see if this is right. I got 700 here, but this makes more sense. At hot idle, it's 10.83. Oh, you know what it is? I know what it is. It's in kilohertz. So this is 700 hertz. This is 2.83 kilohertz. This is 6 kilohertz. In other words, 2,830, 6,000. No, I got it. So in this case, there's your reading. So with key on engine off, we should be reading roughly 700 hertz. And in this case, 2.83, and then go on and on there. So if you're looking for some help, there are some charts. Ford does offer this as well. GM does have it, but you're going to have to look for the mass airflow code to find it in one of the mass airflow codes that you see there to actually find it. So there you go. Now, another popular one, since I saw this already when I made this slide, is PIDS can also means the status of switches. Okay, you're going to notice down here that we actually have, hopefully you can see my cursor, there's the inertia switch. Especially in a no start, crank no start condition, we got to make sure that the fuel pump's running. And if you've been dealing with all the Ford Power Strokes from the 6.0 to 6.4 to 6.7s, you know they use inertia switches. So it is a nice PID to give us, obviously, that the actual inertia switch should be what? Should be closed at all times. So if it is flickering between open and close, which I have seen, or just open, then you definitely know the reason why the truck don't start is because the inertial switch is tripped open, and at that point you got to go reset it, or you do have an intermittent problem with the inertial switch, which in turn you can bypass that inertial switch there. So there you go. So again, the status of switches are also a very valuable thing to get from the scan tool. All right. Please note that, like I said, you got to know your sensors. I showed you the Snap-on Zeus. I showed you some of the information from the service manual. But on a Ford, for example, you're going to notice that Ford uses what they call pinpoint tests. And pinpoint tests, I'm just showing you a brief introduction here of the camshaft position sensor. But in this case, the camshaft position sensor is a input that is used with the crankshaft to give you an RPM signal. So like I said, you're going to look at your RPM signal. Now I know that on the 6064 you can look at your sync signal as well, or your FICM sync. But what about when you don't have that? In this case, you can look to see if it's present. Now Duramax will tell you if the signal is present, but once again, it won't tell you how good it is. Now you're going to find out sensors can use 12 volt, 10 volt, or 5 volt reference voltage. Yeah, there is that across the board on all these different light duty diesels. So what I'm trying to show you here is it's a good idea for you to pull up a pinpoint test on the Ford for that given sensor that you'd have doubts about, and you can start understanding what they're telling you in terms of it. I could tell you right now, in this service info, they're really getting into the wiring of the sensors. In other words, the resistance of the sensor, the actual signal wires, and also the reference voltages. So that's kind of an oldie but a goodie, but thought I mentioned that when you look at sensors. So definitely look at the pinpoint test on a Ford product. All right. I've shown this before, and I believe this one I've shown before. This is an L5P, and right off the bat, there's my OKs right there. Okay. So in this case, I've talked about this before, but I'll just skim through it. When you're looking at PIDS, yes, I'm going to look at desired fuel rail pressure, and there's my actual fuel rail pressure. Obviously, the truck here is got the key on, engine off. We could see that the 43 is the PSI is the actual rail pressure, and desired is 44.52. But you can look at what I was telling you now, what's available since 2017, roughly 2016, 2017 model years. You can now look at the status. So in this case, you'll see the OKs. So to me, this is gold, like I said earlier. It's telling me that, FRPR regulator 2, which is the one on the rail, it's telling me if there's a high voltage to ground. In other words, do I have a short? Do I got an open? All of these are demonstrated: open, low voltage, high voltage. So that's a lot of PID information that's being offered to you there. So to me, that's pretty awesome to have, because you can look at the status of certain components. So what I'm trying to show by that, let me pause here, is that you now can look with your PIDless on GM vehicles the status of certain actuators and what the test status of it is. We've been talking in the past with L5P in regards to the three-phase fuel pump, right? And in this case here, we can see, whoa, right about there. Here you can see the status of the three phases right there. So in this case, fuel pump relay status, okay. Your UVH status, okay. UVH, now in case you don't know what these are part of the three phases here. The rest of them are on this side, but I'm not going to pull it up right now. However, though, he's telling me right off the bat what's the status. In other words, he's doing testing on it, because that's his job anyways. He's supposed to be doing circuit tests to know what's going on. So that helps me a lot when I do my diagnostics here, because again, I can look at the status of them just by looking at the PID data to see if it's okay. So nice. Now, if you haven't taken an L5P class or haven't seen our L5P presentation that we've been done here with Lucas, obviously go to the Lucas YouTube page and take a look at it. There's a whole bunch of them we've done. And in this case, you're going to notice you can actually read your fuel pressure. In other words, what is your lift pump pressure there? And in this case, you can read desired, actual, signal voltage for the rail pressure sensors. And you can also look at lift pump pressure as well. So there you go. So in this case, you have a lot. You can do a lot of diagnostics by looking at your PID data, provided you've done your basics, right? Make sure you've done your basics here. But again, we can look at all that information there. But something that's also very important to understand is also your ignition voltage, okay, battery voltage. And I hate it when a technician has done or supposedly done a diagnostic, or they're doing a diagnostics, and they don't test the batteries. Yes, I'm one of those advocates that any diag that I do, we do a battery test. No ifs, buts, and buts. We have our handheld battery tester. It does a great job. It prints up a report. Every battery's being tested. And let me tell you, you can sell a lot of batteries too, because you'd be surprised how many were bad. I've talked about this before. So therefore, when you look at your scan data, do you also want to verify battery voltage? Yeah. Like when I'm working on a 6.0, we have our 3 different voltages that supply power to FICM, and one of them is relay power. That'll tell you if the relay is working correctly, see if you don't have a voltage drop across the relay. But also you got your main voltage coming into the FICM where you can actually look on the scan tool and see what the battery voltage. So if I have 14.2 while the engine is running at the battery and my FICM voltage for the battery voltage for the FICM is reading 13.1, I'm dropping almost a volt. So that tells me that something is not right. Those voltages need to be very close to battery voltage. So in this case, I understand my key is on, engine off. I'm looking at 12 volts. I'm not liking that signal too much, so I'm going to verify it because ideally, if the batteries are charged, it should be more closer 12.4, 12.6, right? So therefore, any voltage changes is a red flag for me. Now, you're probably not believing this, but let me tell you, that's the difference between a good running truck and a so-so running truck is, are the voltages where they're supposed to be? Not to mention, since we talked about battery voltage, what do we also see right here? There's your 5-volt reference voltage. In other words, he's measuring that reference voltage for you from the computer to see if it's active. And yes, I've had phone calls from guys that don't have the reference voltage. And next thing you know, I said, well, what's your reference voltage on the scan tool? Because I know I can read this. Now, please note, I am looking at an L5P Duramax, a 2017 truck. Do I see this all on a Ford Powerstroke 6.7? No, they don't all give me the reference voltages. So, though I haven't looked at a newer model for a while, but you may want to look at that yourself. So, all right, good information. So again, we got to get up to speed. Here we can see a LM2. This is an LM2, and here I did it with my Zeus scan tool. And once again, there's our OK signals right there on the regulator. Similar readings, different trucks. Obviously, they're both GMs. But again, what I'm trying to show here, and I've shown this before, is the ability to graph and compare one reading with the other. So this is beautiful to me as I set this up and I go test drive, because you're going to look at the desired rail pressure on the upper left, and then you're going to see your rail pressure, and then your lip pump pressure here on the bottom. So as I continue to play this reading that I took, you're going to be able to compare, again, where's your desired, where's your actual real pressure, and where's your lip pump pressure at. By the way, food for thought, I just did a diagnostic last week or the week before with a technician over the phone, and he's saying that, the truck is stalling. He was focused on lip pump pressure, but the lip pump pressure wasn't dropping. And turns out that the problem with the truck was the exhaust was restricted. Yeah, the exhaust was restricted. So in this case, that caused the pump to run slow, slow, slow. So in this case, the rail pressure dropped. The command was trying to get it to go up, but it couldn't, but the lip pump pressure was still maintaining. So obviously everything led to a possible high rail pressure problem, and turns out that the exhaust was restricted. One of those basic things you got to verify. As a matter of fact, I had a text this morning from a guy, similar problem. I said, why don't you uncork the exhaust? Make sure the exhaust is not the problem there. But again, what we're trying to show here, guys, is with the ability to look at your fuel rail pressures, you can graph them and see them. So as a matter of fact, let me keep playing this because it does match just about. Again, we see the graphs of the desired and actual as the engine is running. You can see the rail pressure again, rise 11,000. Let me stop it just about there. You're going to see here that, you see the top right here, and you see it almost matches. So this is your actual real pressure. This is your desired. And you can be able to see that these actually pretty damn come close to each other. Everybody see that right here to right here. So that's the power of a graph to help you analyze. So when you want to review it and play it back, because this is recording as we speak, so therefore I can play it back and see if it actually was good, because I might have done the test drive by myself. So another way of looking at a line graph versus the bar graphs that I showed earlier with IDS. So it works very well. All righty. So the list of PIDS is extensive. So as I look at this LM2, you're going to notice that we got a whole bunch, a whole bunch of data menus, right? So in this case, we have data menus. And by the way, a quick question here. You see heated oxygen sensors. Who are we talking about there? The NOx sensors, right? So in this case, yes, an oxygen sensor is a NOx sensor for those of you who don't know. So in this case, we'll be able to see, again, there's all your data, right? But what I like also while I'm working on this is I can see my battery voltage right there, 13.7 too. So I can see that. But again, your list of available data is quite extensive from GM. Obviously, depending on the scan tool you're using, it's going to show them in a different way, depending what make and model you got. But in this case, once again, you start off looking at your data. Now, let me pull forward here. Oops, sorry, I screwed up there. Let me pause it here. Now, when you look at data, oh, for Christ's sake, I'm trying to mute this. Hold on. One more time. Sorry. All right, now I'm looking at frozen there. Okay, what you're looking at right here is there's your injector commands. There's your injector commands, and there's your timing, right? Now, what I've learned so far by playing with looking at timing is I noticed just by looking at this truck right off the bat, are they pretty damn close to each other? The answer is yes. So what we're trying to teach you here is with time and patience, by working a lot on these trucks or playing on a known good truck, you can actually look at the timing. You'll notice that minus 3.5 is the average I see across the board on these 6 cylinders because this is a 6-cylinder engine. So in this case, I see them that they're all about the same, which is what I'm looking for, on pretty much every LM2 that I work on, right? Now, I know for the longest time we've been working with balancing rates, right? There you'll be able to see balancing rates at the bottom. So balance rate 0.3, 0.2, 0.2, that's telling us exactly the trimming of the fuel that we're using. So very important to understand that. But before I go back to fueling, let me just get this out of the way. As you're looking at fueling is, if we do a basic diag, PIDS to know and view, you got to look at engine coolant temp, right? The engine coolant temp must be at an operating temperature. Obviously, we don't want to see a minus 40. We want to see engine coolant temperature get up to speed, meaning that I'm looking for 185 minimum. Ambient air temperatures are given. It should be whatever the ambient air temperature is. RPM signal as I crank, even though I got a crank no start maybe, I want to see if I'm getting an RPM signal, right? Now, you could have a situation where you see an RPM signal, then it goes away, then it comes back, goes away, comes back. You definitely know you got a problem right there. Should it be skipping in and out? No, it should not be at all. And by the way, if you've been keeping up on latest on in-depth diagnostics, since I've been working more with gasoline again, we're now seeing timing wheels or reluctor wheels on camshafts and crankshaft starting to what? They're starting to shift. So therefore, we're seeing that problem, which will throw a timing code definitely or a no start, and it'll just feel like the timing's advanced, right? So in this case, definitely a problem that we're going to come across. So we want to see a steady RPM signal, but we may have to use a scope just to verify if we are aligned with the camshaft. So that's new stuff more that we're doing. Obviously, we talked about fuel rail pressure action desired, the lip pump pressure, but then we got to look at MAP, barrel, mass airflow, and battery voltage to see what's coming in. These are basics that I need to see minimum to actually do a diagnostic, right? So if the lip pump pressure is not available, I'm gonna have to go measure it. But yeah, it's something you got to get out of the way. So definitely want to know those PIDs. Okay, definitely do that. So my suggestion to you, like I said, is get a known good truck. Let's say you work on a lot of 6-7 power strokes. Start recording some of those readings, take pictures, snapshots of a known good truck, so you can have that on hand, maybe with your phone, and be able to view them to see, hey, is this even close to what I'm working on? This will help me a lot. So definitely, it'll help. So Matthew, you asked me real quickly. I'll get to that here. You asked me a question of how did it the restricted exhaust affect real pressure? Because the engine was trying to run, but since it couldn't exhaust, it's starting to build up a lot of back pressure to the point that the engine was starting to lug down, and terminally lugging down. The RPM went down, and in terms of pump wasn't turning as fast, not generating the rail pressure until eventually it died and rail pressure dropped. So there's your answer, sir. Hopefully that answers your question. Okay, so those are the bare minimums that we need to have when it comes to PIDs here. Almost done, don't worry. So what should those readings be? Like I already covered that, right? Barrel, ask Siri or ask your whoever you look at your weather channel app and look at what the barometric pressure is. And guys, you could do that with key on engine off with those trucks that don't use barrels but use the map as a barrel. You can use the map sensor too. So look at both barrel and map if equipped or just map. And what you want to do is see if that actually matches because we have seen some as off as a half a pound. And that's enough to cause a drivability issue too as well. Because remember, the map, especially the map, that is what we call the load sensing sensor. So he's the one that indicates load along with mass airflow, but map is more critical. There you go. So in this case, we saw already what the hertz of frequency we should see for example, on a Duramax for mass airflow, right? Actually, it was a Ford. And then we got our engine coolant temp. I haven't said enough about that yet, right? Engine operating temperature along with ambient air temp. So use a little logic because a lot of guys tend to forget about logic. Okay, I'm taking a minute. I'm going to scroll down the list, see if everything is where it's supposed to be. And guys, when I step in from a shop and they want me to look at a truck, I follow that same sequence of events because, okay, what are the inputs that that computer is getting? What are these PIDs telling me? Because I cannot look at fueling if I don't know what those sensors are at. Please understand that logic. I know a lot of you guys, I know a lot of you know this by heart already, but heck, don't look at balancing rates. Don't look at fuel trim if you haven't verified those PIDs. Because if the engine is running too cold, are your fuel trims going to be accurate? No. If your balancing rates are off, could that be affected by a skewed map sensor? Yes. So you got to verify it. So in this case, use la cabeza, like we say in Spanish. Use the head because you're using your logic because something as basic as are you sure that all the cylinders have good compression? Hmm. So many scan tools nowadays have stepped up to the plate. I actually love my power strokes. Does this look familiar? All right. This has been a very good info thing. But you're going to notice, like we saw with Duramax, he can give you a degree count if there's low compression. But we have graphs available for Fords. Sorry, I'm taking cough drops because I'm coming off a cold, but nice, huh? So in this case, that was a good friend to tell you what was going on. But there are more PIDs that are, popular phone call I get. Let me put it to you this way: is, hey Tony, I'm looking on a Power Stroke 6.7. What should be the range I'm looking at for the cylinder mass adjustments? Well, here's one right here. Please note that Ford does not give us a spec for this. They don't. But you got to use your brain a little bit. Look at the scale here. Minus 4 milligrams of change to 4 milligrams of change. But if you look on the far right, and hopefully I can zoom this. Yeah, I can zoom it. You're going to notice that the readings are in what? The readings are in micrograms. So in this case, 1 micro is far less than a milli thousands versus millionths of a change. He's telling you he's making millions of a change. So when I look at the overall picture here, is this normal? The answer is yes, it is normal. So as this truck is idling, as you'll see, I'm going to let it idle, you're going to notice that 0 represents the program fuel value. He's going to have to add fuel. He's going to have to subtract fuel. He's going to have to add fuel, subtract fuel. And those are in micro changes. This is a very good running truck. But if I get into the 2 milligram change, you're going to start seeing a trend. So if you suspect you got a cylinder issue or an injector issue, yes, you're going to go ahead and see that bar or that line here go far right or far left, indicating underfueling or overfueling. So therefore, this is a good telltale to tell you what's going on. But please note, again, the scale is kind of self-explanatory. We're making micro changes in fueling, which is great. This engine's running great. This is normal. Do we always want to see 0? No, that means that's the program value. So therefore, that can change. But again, don't look at this if you haven't confirmed all the other PIDs. Because, and let me give you an example. Typical injector issue is if it's leaking, you got a nozzle leaking, boy, this will be way to the far left because it's minusing. Minusing means to subtract fuel. He's trying to back off on the fuel. So that's classic. This is where I've used the fuel additives like the BG245, which is my favorite cleaner. I've taken readings of it the day before, then the day after running BG245, and you could see how that squeezes all together because of the fact that the nozzles were definitely dirty and that cleaner worked very well. So again, I use that for that. So therefore, creating a better spray pattern coming out of the injector. Now, if those of you that don't understand what I'm looking at, you haven't had a common aero class, this is telling you what the adjustment is for fueling at idle. This only occurs at idle, at operating temperature. So in this case, he's adding fuel, subtracting fuel, adding fuel, subtracting fuel. It's a closed loop system that's using the crank input to actually need to either to add fuel or subtract fuel. But again, it should be no more than 1 milligram. But if you see one of them sticking out more than the other, that definitely is a red flag that you probably got injector nozzle issues, which again, you can run a cleaner to fix that, unless you got low compression. But then on this Ford product, you can run a relative compression test. So there you go. Well, I'm just about done, guys. Hopefully that helped you out. Some quick tips to help you out. Definitely work with known good vehicles. If you have a scan tool that you haven't looked at the other features, maybe you have an Autel, or you got Geltis, whatever it is, start playing more with them on known good trucks and get acclimated. Heck, even if you have a gasoline car and you drive that home, that's your commuter, just connect the scan tool and see all the capabilities of what your scan tool can give you, because a scan tool is only as good as the technician using it. So, Mr. David, how did I do?
I think you did excellent, as usual. Really appreciate all that good information. In fact, I had a couple of comments down here thanking you for all the good information as you do every month. It's tremendous information and extremely helpful as well. The one thing that came as far as a comment or a question, when you were saying and you showed some of those charts on there, is that available in Spanish as well? Would you happen to know?
What do you mean, the graphs?
No, not the graphs, but say, for example, earlier on you were talking about, there was a chart, and the chart said, that's supposed to be 5 volts, and the other one's supposed to be, positive or negative, and in other words, the diagnostic chart. Is that
Some of them,
interchangeable in
yes, some of them,
manufacturers?
no. General Motors has some of them in Spanish. I got to look up where they did the cutoff, but they do have some.
Okay.
Uh, yeah, they do have some in Spanish, but not all of
Okay.
them.
Okay. So you can probably select some of them a different language. Yeah.
Yeah, but you have to go to that factory's website, or if you have Identifix, you can do it in Identifix. But if you don't have Identifix, you're gonna have to go to the specific factory website, like Tech Authority for Ram,
Okay.
GM Tech Connect for GM, and then Ford is motorcraftservice.com. So
Okay. Very good. And for all of those of you who are listening, just want to remind you that all of these presentations that Tony has done for the last probably a couple of years for Lucas Diesel Systems, they're all available on our YouTube channel. So if you go to the YouTube and you go to the Lucas Diesel Systems channel, you'll be able to find all the recordings of all of Tony's webinars, as well as Tony places them on his website as well. So you've got two locations. Another comment on here, Tony, was they like your new slides. It shows you an engine and then the wording on the right-hand side there. They're like your new slide. So that's a good thing.
we're trying to
The other
put
thing
more
is,
graphics in.
okay. Let me see. The other thing I was going to mention was next month, October, we're going to have a presentation from Tony, but it's going to be in Spanish. So stay tuned for more details on that presentation in Spanish. And then for those of you who might be interested, Lucas Diesel Systems will be participating and attending an event in Puerto Vallarta, Mexico. It's called Alianza Diesel, and that's going to be a mini convention in Puerto Vallarta, Mexico. And Tony will be one of the presenters there as well. So anybody who's interested in that event, if you either send an email or a call, either Erica or myself, we can give you all of that information if you're interested. Just keeping in mind the event will be totally in Spanish, 100% in Spanish. So if you don't understand Spanish, you'll be out there at the beach and not be able to understand anything. That pretty much does all the questions that we have at the very present time. I think you answered Matthew's question as well earlier on.
I put my email up there. So those of you that want that Duramax book, send me an email. I'll give it to you free of charge. It's a nice book. It's free. It's good info. It's an older book, but it still applies till today. So
Very good. Appreciate
don't
that,
say I don't give
Tony.
anything away. Jeez.
All right. So without further ado, thank you very much for everybody for attending. I know we offer a lot of very good information. When I say we, Tony offers a lot of very good information. And keep Lucas in mind if you are in need of any components or you want to do any remanufacturing of injectors, need turbochargers. We have a whole array of products available. So with that, I want to thank Tony once again for the presentation. We very much appreciate it. And we'll see you again next month. Thanks very much. Take care. Goodbye.
Take care, everybody.